session of Fusion 360 workshop. Now I invite Nihal Chetan to begin today's session.
Thank you, Dave. Okay, so I'll be continuing from where I left off yesterday. Let's see. I hope I'm audible. Okay, so as I mentioned yesterday, I hope some of you have got the opportunity to test out some of the stuff you studied yesterday, or I told you yesterday. It's fine because there is some authorization or confirmation of those things which I mentioned earlier required, so I can understand if not all of you could get access to the software right away. But I think that would help. Okay, so yesterday I told you most of the stuff pertaining to I think there was this one. I think I told you most about the sketch tools which come inside the 2D tools, I guess. Most of these were explained. Some of them, a few of them, which are pretty interesting and pretty useful, like this one right here, project, and some of these constraints. Most of these constraints are auto-applied. You wouldn't probably need to apply most of them manually, but we'll see if we can include that in today's session. Definitely, project is something that I would like to show you. So I've planned a basic engineering drawing, right, of a certain part. It's pretty easy to understand the dimensions. So I'll show you how I would approach a certain drawing such as that. It is not necessary that you guys need to follow the exact same approach. It just shows you how the tools can be used along with one another to achieve the final product, right? Yeah, so leaving the sketch for now. So there are a bit more, let's say, 3D tools to be used here. I'll just hide the existing ones. By the way, the 3D objects that you do create, right, they're saved as bodies. You can see here, if I hide one, it's this one, right? And another one is this one. So these are the basic body meshes that are created as a result of your 2D sketch being extruded or pulled out or whatever, right? So as you can imagine, these are just individual parts. So if you're trying to couple more than a single part, right, you have to use another form called components. So the basic thing is you just click on the body, right, and there is this button right here. In assemble this new component, right? You just click type standard from bodies and select a body and OK. And as you can see here, there's a new thing that has popped up, and this can be moved by simply dragging the mouse. So this is a different type of mesh, not really a different type, just a different name, so as to differentiate between these two, right? Only these component parts can be assembled. So I'll just leave it at that. This is something that just came to my mind. I'm just doing a couple of undos with Control Z, of course. Let me just hide these bodies. Okay, so as I mentioned, most of you can get away with using this revolve in, I guess, extrude for most of the purposes, right? So there are some other options, as you can see here. Emboss is basically, most of the time, I guess it's for not aesthetics, it's more for visual aspects rather than technical aspects. So we'll leave it at that. Hole, it can be used. Most of that stuff can be done with extrude as well. So you can see here the box, the cylinder, the sphere, the torus, coil. The coil is actually individual, that's fine. But the box, the cylinder, sphere, and these can be replicated with those basic functions which I've showed you earlier. Earlier, by that I mean yesterday. Torus is basically just a revolve function of a circle at an axis which is far away from the sketch. So as you can see, there's a midpoint right there. I can show you what a torus is, I guess. See, basically we just draw the inner, the base circle of the torus, and it just generates a 3D structure. It's not that important. It's I guess it's more, you can have a more controlled approach while doing the whole revolve thing, right? I just cancel that out. Some other features I'd like to show you is the sweep and the loft, right? So I'm not really sure if I explained yesterday. Like, let me just create a basic shape of sorts, right? And let's just, okay, I'm just creating a random shape. It does not have to have any consequence, right? And let me just use revolve to give it some depth. Angle axis, and it's just a very basic shape, right? There's nothing to it. So as you've seen earlier, you can create sketches on these primitive planes, right? As I've shown you, x, y, y, z, x, z, all that. And you can also create, sketches on already developed planes or already developed surface, flat surface to be exact. For example, as you can see here, this is getting highlighted when I move my cursor over it. Same goes for the bottom face, right? This is because both of them are flat surfaces and you can use them to create your new sketch, right? So if I just click on this, see, as you can see, I'm just creating some random shapes. Nothing useful, just creating some random shapes. If I click finish and if I select these, right? By the way, you can select different entities which are not all clubbed together using shift and click, right? So if I shift click again, it should be deselected or something along those lines. Let's say, okay. I selected them again, so I can extrude them again. So they form another sketch, right? So this is one possible option. So I think I have not mentioned earlier either. Since this is a new sketch and this is a new body being created, or it's a new feature being created, right? There are options to either add it to the existing geometry in contact, or you could create it as a separate entity. So if you look here, there's an operation called join, right? I think this should be the default one if you're trying to create more geometry, right? If you're trying to separate it, right, there's this new body option. And if I click OK, I think it's lagged a bit. Okay, that's fine. Yeah. As you can see, these are the initial bodies. I just hidden them for ease. So this basic body is body 5, right? If body 6, body 7, body 8. So all of these are separate bodies, right? So there might come a time when you have to create it as separate bodies because there are a lot of parts in close contact and you don't want all of them to merge together. You just want specific ones to merge, right? So you split them at first. Then you just, there's this, as you can see in the modify tab, right? I haven't shown you this much. Fillet is basically the same fillet as this is in 3D, but as in 2D, it just goes in a 3-dimensional direction. So if I click fillet and if I click here, right, you can see it will smooth off the edge. You can definitely use it. I'm not using it here. I'm just showing you how it goes. You can just pull it or you can give a proper radius. This is the tool. So what I wanted to show you was combine, right? Combine is very important. As I told you, you might have many parts in close proximity and you might not want all of them to mix together. So you can first create separate bodies. This also applies for revolve, I would assume. Yeah, it should apply. So once you create the separate bodies, you just click on combine. You have target body and tool bodies. So the body to which you want to combine the other parts should be your target body, and the tool bodies should be the other ones, right? So there are 3 tool bodies and 1 main body. The operation is join. There is cut and intersect, which are pretty self-explanatory. And you can create components from them right now, which I'm not doing, or you can keep tools. So if I don't tick this box and click on OK, it just creates a single body, right? As you can see, it's just a body 5. However, if I was to, as you can see, this is the timeline. All of the progress made here is shown. The changes in the 2D sketch itself will not be shown on the timeline. So like anything you do on a single 2D sketch will be shown as a single element on this timeline. So that is something you need to keep in mind. That is, once you make or once you create or delete features in 2D sketch, you cannot get them back. As in, you cannot get them back more than what you can undo, right? You can undo some bits, but once you exit out of that sketch, you cannot go back and call back those features which you deleted. So finalize your sketch first and then move on. All right. Okay, so I'm just going to double click on this feature, or just right click and edit feature. Double click works the same. If I were to keep tools, right, for some reason, okay, the need might arise or might not arise. And if I click OK, as you can see, there are these 3 tool bodies are still remaining. Even if I minimize them, the entire body file will. So the body file will be the entire joined one, and it'll keep the tool bodies as well. You can see clearly how those work. So similarly, there's another feature of extrude, right? I have shown you to make holes on surfaces, right? So as I've shown you earlier, if I click on these, the arrow usually points outwards, like as a default option. I can pull it out. At the same time, if I pull it in, as you can see, the red denotes that it is drilling, or it's just creating a cavity into the existing surface. So I just click OK, and as you can see, it drills into the existing object. So as I've mentioned earlier, you can use the hole tool as well for more, I guess, shapely holes. I guess it has stuff like simple counter bore, counter Sankhya. I'm not sure if it's visible enough. This cannot be, what do you say? This cannot be magnified. But so the simple hole should look like a twist drill hole, right? The one with which you can obtain, like the one which you can obtain from a conventional drill. Counter bore and countersink, just understand the shape for now. In most cases, you won't need it. Yeah, you'll probably be more concerned with the features, with the other features, but you can choose those as well. I guess you can just click on the surface and you can move this, right? It snaps the points as well. So like I mentioned yesterday, you can use a separate sketch with some points if you want to mark the points out first. You just place it there and it snaps there, as you can see. Let me just reduce the radius, and if I click OK, it should, as you can see, it's not that clear, but these are all flat bottom holes, right? But this has a point at the base. I really cannot show you that feature any clearer. Yeah, I guess if I were to like select that feature and go to the side, you can see how it's conical at the end. So that's just the hole tool. I would assume you would be using extrude more often. That's fine. You can use the hole tool as well. And of course, these are more, I guess, it can be bit, the thread tool, you just select the cavity. I'll just choose one of these cylindrical cavities, right? And click the thread tool. It will create a thread-like pattern on it. So if, okay, see this option here, model, it's turned off by default because if you do click on model, it will actually create geometry. What you see here is more or less an illusion or the appearance of a thread, right? Not an actual thread. So it can just, there's some stuff about threads right here. It's about right hand. The M75 usually stands for, I guess, diameter 75 millimeters, something along those lines. There are types of thread profiles, different standards. You might be familiar with the isometric profile. Yeah, it's usually used here, I guess. The right hand, the left hand. There's a slight change. I don't know if you can easily see it, but there are things like that. Model usually does put a bit of stress on your system, so you can avoid it most of the time. In an industrial application, you might have to use it, but I would assume they would not actually need to print out these holes. They'd rather make the holes themselves after the entire printing process or the cutting process is done. So it's an option. I'm not clicking it. It might interfere with the working on the computer for now. I just click cancel for now. If I had clicked OK, it'll just produce a pattern of the hole. That was an internal hole or internal thread. I could have made an external thread as well. I think if I clicked on something, okay, let's just say I just clicked on this and just extruded. Nothing new, right? Just click on the thread and click on the outer surface. It creates an outer thread as well. It's pretty fine. So it's used to create both outer and inner threads. So just leave it at that. Then some other features I would show you is pipe. Pipe feature is pretty useful. I can show you the sweep and loft. Yeah, sweep and loft. Sweep and loft are pretty. I haven't used it as much as I would have liked to, but sweep. Let me just delete whatever is remaining. Yeah, yes. It's fine. Okay, just deleted a bunch. It's fine. You usually don't delete like that. I'm just showing it to you for convenience. I could delete this. It's fine. I could drop. I don't want to delete that. So anything that's not white on the highlight, if it's not white, it's usually some kind of error. I guess the yellow errors I think you can get by. And if it's shown in red or something, I get a bit more towards the red, I guess. That would be an unacceptable error. So that is the usual, let's say, UI in most of these programs. Like yellow is so and so you can manage maybe, but red usually causes much more problems towards the end. Okay, so let's say I'll tell you about loft first. Let me just try to open a. So I guess a shampoo bottle would be the best example. Shampoo bottle. Yeah, I guess this might be a bit too complicated for me to make. Let's just take this shampoo bottle. As you can see here, that's fine. As you can see here, right, this particular shape cannot be generated with extrude or revolve that easily. It'll take a lot of cutting and placing. It might work. I wouldn't recommend it though. So for things like this, loft is made. So what loft does is it basically automatically connects different profiles. I'll show you in a while. So you can assume that there's an ellipse here, a bigger ellipse in the middle, a smaller ellipse at top, right? So if I found a way to combine all of those, I could get a shape similar to this. And I would assume that is how these shapes are made as well. Let me just minimize that for now. So that will also give me an opportunity to show you these construct planes. As I've showed you earlier, you can either draw your sketches on these existing planes, right? Or you can draw your sketches on what generated surface such as this, maybe this, anything that's flat, that exists on a single plane, right? You can draw on those. You cannot draw on curved surfaces, I would assume. Yeah, you cannot. It is highlighting some other plane. Yeah, it is highlighting this flat surface. So you cannot use curved surfaces to draw or sketch. So you have to have some kind of reference planes for you to work on, right? Let me just minimize this for now. So that is when these construct plane options come in handy. In construct, there are a lot of options. A couple of these options are very handy. I have found it a bit more difficult to work in SolidWorks, or maybe they have updated it. I have worked on a much older version, right? These options are very useful, as I'll show you that now. Okay, click something, just leave it. So let me just show you how you would presumably create the shampoo bottom. I'll just choose this bottom face right here, right? I haven't shown you the ellipse tool yesterday. You could have just checked it out yourself. That's why I'm just choosing the ellipse. As you can see, you just pull it out and you decide the height of it. To be honest, I don't think I have checked the. So that's 200 and 100. Yeah, that's fine. Let me 200. It's fine. So I have this plane surface right here. So if I click on construct, right, I can use this surface to create another plane. So this the default option is offset plane. If I click on the drop down list, the first option is offset plane. So you can offset a plane from an existing plane. I'm going to use that now. Just offset plane, click on this plane. I can just drag it down and I can use that to create another temporary plane. This shows up in the construction options. It's very useful. You'll definitely find use for it. So you click on this plane and I click on sketch, right? As you can see, where I'm drawing, it's an entirely different plane. If I click enter, right? As you can see here, this was the earlier preset plane. This is the existing drawing, or the current drawing lies on another plane entirely. Let me just undo that. Since it is centered, I can use the center directly, right? But assume it was off center, right? It was somewhere to the left or right. How would I get that center? So that is where a very useful option comes, right? It's called project. I've shown you earlier. The shortcut is P. It's located in create and it's down here, project, right? So what project does is, right, it projects whatever surface you select, surface or feature you select, and projects it flat onto the plane you are currently sketching on. So for example, if I click this project here and I say, I guess you can choose either one. I think this is an auto select one. That's fine. I usually leave it on. I haven't checked it out yet. If I click on OK, as you can see here, it has exactly projected what I see here onto this plane. I would guess most of the participants in this workshop are in their second semester, right? So you might have gone through engineering graphics, most of you, I would assume. So you would have heard of projections, like how you see one thing when it's projected on a particular plane. That is what this project does. So this helps us get an average shape, right? This helps me get the center. It was not required. I just showed you because I wanted to, and I'll just create an ellipse. As you can see here, the projected one will be in a different shade. It's violet for me. That could be used as a closed profile as well to extrude or do something along those lines. Here I'm just going to choose the let's say 100. This is way too low, but it's fine. Let's just 60. I'm just eyeballing most of the max here. Just bear with me. So I have two surfaces right now. So if I were to create loft, right, I could just select this one and this one. And as you can see here, they kind of joined both the bodies together, right? If I had more surfaces, I could join more of them. So I'll just draw one more and show you how it could be done. Let me just, I'm going to scale it a bit more. Let's say 150. That's fine. It's not exact. It doesn't have to be. I'm just showing it to you. I click on offset plane again. I click on this one. This time I want an upper one at some kind of height. It doesn't matter. If you remember, I use the middle mouse click to pan the whole screen, right? And I use shift and middle click to orbit the screen. Then you scroll up and down to minimize and maximize. Oh, it's a bit awkward angle. It's fine. So I just click on this, create sketch. I create another ellipse, right? There is the center point already, hence I'm not projecting it again. It's fine. You can project it if you want. I'll just finish it right there. See, now I have three surfaces or three closed planes, which I can use the loft command. As you can see in the picture itself, it can join different surfaces together. So you just select this one, you select the next one. It already creates a profile. Once I click on the third one, it should modify the profile in according to that. See, as you can see, you get a more curved shape, right? So this is just the profile section. As you can see, there is a section called guide type as well, which means rails or center line. So this can be used to modify the shape a bit further. I can show you an example. Let me just click cancel for now. Let's say, let me just look at it straight on. If I were to create, I'll show you. Okay, so this plane is already centralized. So I'm just going to use that to create the exact shape of what I want. Okay. I just click that. It's just rotated. That's fine. Let's say I want to have a much more sharper feature like this. I'm just drawing a line, so this will serve as a guide. Okay. If you're wondering how I'm drawing the curved line, basically you just click and hold, right, and it goes to that point. For some reason, okay. So here I need this end, right? So since that is not projected, I can just click on this element from another plane. I just click P for project and I click OK. And now I have that particular point with me, so I can easily clip onto it or snap onto it. Okay, I just did that. I'm almost sure that only a single rail is needed. But for convenience, let me just mirror this across, let's say, this line. I'm just going to select it and turn it in construction line, just so you can see the difference, right? It's fine. I just rotated it from the top right. I am going to mirror this. I chose the two elements. I click on the mirror. I click on the mirror line, and it's generated. Okay. So as you can see, I made a basic. So earlier it was entirely curved for the lower section as well and curved for the upper section. So if I did this right, it should make a more straight cutting here, and then it should curve only at the top, right? We'll see what happens. If I finish sketch, now I click on this part is not required. It's just part of the sketch. It's fine. Create and loft. So first you click the profiles, preferably in order, right? I think it should be in order. I click the bottom one. I click the top one. So as you can see, I haven't given the guides yet, and hence the shape is same as the previous one, right? So if I did this right and guide type rails, not center line, rails, and I click add, and now it's in rail. If I select this, as you can see, when I selected one rail, it shifted the entire thing. It's a pretty nice shape, to be honest. But I want it more symmetric, so let's say I click one rail and it did that, right? If I click another rail, it'll confirm the shape to that exact one. And now you get that almost. Granted, it doesn't look exactly like this one, but I didn't use any dimensions. I just did the whole smoothing thing. I guess this plane could be higher on, and that might help a bit. Those are some ways you can make these. There should be actual measurements to this one. I just made it simply. So let me just, okay, giving a rounded bottom wouldn't help the balance much. Let's keep the bottom flat. Let's just give it a fillet. Once again, all these are completely unnecessary. I'm just showing you just because I can. I gave it a kind of a round. I still have a flat face, so I can construct more things on top of it. Let's say I just chose this one, right? Do I get a center point? Yes, I do. I just chose the extreme end. I'll just finish it. Okay, I just extruded it. I've shown you these features earlier, that's why I'm not explaining as much, right? So you know what? So I think this entire thing is a single body, right? So there's this option, right? I think I can show that. It's called shell. As you can see, it basically shells out the interior. So this entire thing is a solid block. That is not how usually bottles are, right? You start from the top, you clear the entire top, and you have a kind of thickness to the walls. So I'll just try it. I'm not sure if it will work exactly as I want it to, but we'll just try anyways. If I click on this, right, and I choose the shell option, which is found in modify. Guys, in most cases, I guess you'll have these, the interface shouldn't have changed as much. I haven't updated this version in quite a while. It's usually auto update, but I haven't checked it myself. So usually all these options would be exactly where I show you. In case not, it should be in either one of these, right? It usually doesn't change because it has a lot of development put into it. It should be the final form for now. So in the modified tab, there's this shell, right? So I click the top face, and there is this draggable button. I'd recommend not to drag it because there's a lot of computations taking place suddenly, and it might cause your computer to lag out. Instead, I'll just give it, I don't know, maybe 2 mm thickness and then press enter. I think that would probably slow it down as well. Yeah, try adjusting the values of exactly. It tends to create problems. I would assume that it's got some. I just remove that shape for now. Let me just remove that. It's fine. As I told you earlier, it's a bit things like shell, right? If you use it on such curved surface, it tends to create problems. That's fine. We can try it again. Let's say 1 mm thickness. Oh, that worked. As you can see, it's a hollow bottle right now, right? Okay, it looks too thin. Let's just give it maybe 3, not 31 3. Yeah, I guess that worked, right? It seems much more like a bottle, right? You can use it now. I want to give threads here. That's why I did this whole circle thing. It should have worked. Maybe we can still make it work somehow. You know what? I'll just try it once again. Maybe the thickness was a bit too much for it. It's pretty understandable. I'll just give it a very. It's fine. It's very thin. I know. It's fine. Should be fine. If I still click and I'll just give it 1 mm. It works now, right? See, as you can see, it shows the inside of it. It's fine. It should be fine. Even if I give it 3, it's still fine. I don't know. There was some kind of error earlier. I might have did something wrong. It's fine. So now you have a particular kind of bottle, right? You've seen loft. You've seen how I can generate shapes on top of shapes, right? Okay, if you want, you can make this. You can just select that kind of cylindrical surface. You can give it a thread, like usually bottles have, right? Okay. Okay. So, okay. I'd like to show you another option. This is inconvenient. Let me just. It's an isometric view just for comfort, right? So I told you earlier. So I've shown you loft. Then I told you I'd show you sweep, right? The sweep is pretty useful as well. I guess. Let's say this was a kind of a mug, right? It should have a handle, right? So what sweep does is it drags a certain profile along a certain line. I'll show you how it works. As you can see the picture below, it uses a circle, right? That blue part, it uses a circle and drags the circle along that particular curve. So first you'll need a curve. So I'll just create a sketch. Is this one is still centered, so I'll be using this one. I'll be using this spline. No reason I could have used this straight one as well. I'm just using this just because, right? It's not exactly on the surface. I could make it on the surface. I could show you how that's done. If I just edit that sketch, right? Now this thing, I probably do not have any, what do you say? The snapping points. So I can use the surface, right? I can create, project. See, I use project quite a lot, so I can get these shapes quite easily. So if I'm not wrong, that okay, it doesn't help my case at all. I guess it doesn't. That was pointless. I guess that's fine. It doesn't have to go in. That's how I would have done it. It's just not working right now. It's fine. So now I have this surface, right? So we need a surface perpendicular to this path, right? So in order to obtain that, you go to the construct, right? The offset plane is the default option, but there is this option towards the end, plane along path. So you just select that. You just select your path, and as you can see here, it creates a plane which moves along perpendicular to the path you already have. So I'll just keep it at the end because I have to extrude the entire thing. So it's good that it's inset a bit, so the end doesn't show out. I just click OK, and my computer has hung up. It's back. And if I just create that plane, right? I create a sketch. Let's say I give it a simple. I just give it a rectangular frame for now. Okay. So my objective is I should use this rectangle and I should drag it along whatever. Okay, that doesn't work. Fine. When you work on it as well, you'll have a lot of these rotations and orbital movements, right? So bear with me. So I want to use this rectangle and drag it along. It's to be noted that I think both of them should be separate sketches and not the same sketch. I think that was a problem. I'm not exactly sure, but it's better this way. It's better practice. So I can select sweep, right? Sweep. You choose the object to sweep, and you click the path along which it should be swept. Since it intersects with this body, that is why they're showing the red sign, which is the cut. You can just use a new body, right? Or you can use a join. It might interfere with the thing. That's fine. Nobody's going to see it anyways. I just click OK. And as you can see, that is how the sweep works. You sweep it along a particular path, and now you have a pretty wonky handle, right? So if I'm not wrong, that rectangular sketch I created, right? If I was to modify it, and by modify I don't mean delete it and create another one. If I were to modify it, like, I don't know, maybe let's just give fillets, right? This is 4.5 degree fillets all around the side. I'm just selecting different corners, 4.5. I just fill it with that much, then I click OK. Yeah. As you can see, the change I made in the sketch, right, it has been grafted onto the handle as well. So as I told you earlier, since there is this timeline approach, right, if you edit the feature in the past up to some certain extent, right, if you modify a feature in the past, that is carried over to the extreme end of the face. So if I were to drag this line behind, it will probably lag out. It's going to lag out a lot. Let me just play this. So those are just some parts of the timeline. Just bear with me. It's played it. It might have crashed. I can understand if it did crash. Yeah. I guess you have to play it from the extreme end, right? You don't really have to do this. I'm just showing you that it's just showing a kind of process diagram, right? So each individual element, as I told you earlier, the 2D elements are not shown as separate entities. Rather, a single sketch is shown as a single entity. The 3D features, each 3D feature is shown as a separate entity. So let's just keep it there. So I showed you sweep. That's good. The combine is very useful. Another one is split body. That is pretty useful as well. So imagine I have to remove, let's say this threaded part, right? I had to modify that for some reason. I had to split it from the say body 7. Shampoo. So I choose split body. Body to split is you choose the body. You choose the splitting tool, which is the plane, right? I choose this flat plane, and it shows you how it's going to cut it. Okay, it's fine. Doesn't intersect with this one. If I click OK, it generates 2 bodies, right? So this one is separate. That one is separate. It can be used. It's not. I have used it quite a bit. Like you, let's say you're creating an enclosure for some particular project, right? You can use this kind of an approach, right? To first create the basic 3D box, then you can split it into pieces, and then you can make those joints separately. I found it to be a much easier approach to doing this, right? So there's that. So I covered most of the 3D features. The 3D, let's say, where is the 3D mirroring? Mirroring 3D is basically the same. I could just mirror it across the surface. I don't think I need to show you that. Pattern is basically the same as that of the 2D pattern. I would like for you to try it out. I mean, everyone gets Fusion for free, right? Just try it out. It's much easier that way. So this covers most of the let's say modeling things, right? Modeling stuff I would use, or that would come in handy very frequently, right? Some of these other things would be used as well. I haven't used many of these because the application where these things come in, right? It would be like I guess Autobile would be one of those options where you would have to have a certain cutting plane of various shapes, I guess, and use it as much. You can get away with most of the work with these kind of tools. So I did want to show you. Okay, let me just save this for now. It's fine. It's Control S for save, as in all other programs. Let me just open a new design. Okay, so I thought I'd show you. I use different monitors. That's why things don't open up on the same screen. So I think you can see this picture right here, right? So what I want to do is, as you can see, this is a kind of engineering drawing. Don't expect anyone to actually give you this kind of a drawing on their own, right? You would have to create this in most cases, or you would have to come up with a design. This is just a ready-made drawing, so I can show you how. Like I have one view of a 3D object, right? This is very symmetric, so it's much more than what I need, right? You can model the same thing in Fusion 360 by getting this picture alone. In engineering graphics, you might be familiar with a plan, elevation, side view, and similar other names, isometric views. I guess this would be an isometric view. It looks like an isometric view. So this is something I just got off online. It was named something engineering graphics, something. So it's probably a question paper of some sort. So we can use this. I can show you how I would model this, right, in a simple approach. And I think we could use most of the tools as well. Let me just open Fusion and okay. So I'll have to minimize it again and again. I don't. Okay, I might be able to import it into this. Usually there is an option like that. Yeah, it didn't show. Insert from my computer desktop sample. Oh, there is an option. Okay. This is. It's fine. I guess it can stay here. I don't. Okay. Now you can see it better, right? I haven't really tried out that option yet. I usually just put it on my second screen, but this way you guys can see it as well. I hope it's clear. It might be a bit edit canvas opacity. Oh yeah, they I guess they voluntarily reduce the opacity so that you can work through it in a sort of sense. Okay, let me just show you. So is this that's fine. I'll just create it on the side. As you can see here, there are a couple of shapes. Most of these are simple shapes, right? As you can see here, this was supposed to be a circle, but it was cut off by the sides. So you can use a bit of that project stuff, like the project tool I showed you. You can use that. These are more or less simple shapes. All of these have values shown here, right? You can use most of that to get away with what you want to do. So I'll just start it. I'll just show you how I would work on this. So that would maybe help you get an understanding of how to proceed when you get something like this, or when you have your own projects to work on. Let me just start a new sketch. This is intersecting with this one. It's fine. I'll just draw it on the side. I'll start as L piece first. It's not a perfect L, but I'm going to treat this as an L, right? So what do? I just did the L piece first, right? As I've told you, you can have different approaches. I just drawn an L. Since all of these have to be scaled separately, it's better to go scaling with the dimension tool, right? So this says it has 20 length here. Then it shows 50 and 25. So 55 and 25. So that's 80 and that's 20, that's 100. So I'll just, okay, this is going to be much bigger. Yeah, that was to be expected. It's fine. At least you can see it, right? So this is 100. The height is 30 up to this point. It's 10. Okay, so so I can just choose this part. It's 10. Let me just choose this thickness first. So this thickness should be, they say I think you are familiar with these dimensions. So they say it's R20 and 520, right? So 520 is like 520 is 20 diameter. So that's referring to this particular a smaller circle, and R20. So R20 is radius 20. So that's like diameter 40. So they'll usually refer to the outer one. The dimensioning is not perfect, but it's fine. So if you rotate that to this part, that should be a 20 thick section. So you just select, you give it 20. It's going to scale by quite a bit. It's fine. It happens. I've given this as 10. That's fine. And this part is 30. So it's shown here. It's 30. So I'll just give it 30. That should fix it. Yeah. Now it's a similar shape. So I'll draw that at first, right? So it has to be extruded by 35, as you can see. I know this might be a bit faster than your comfortable bit, but I don't want to explain all those easier functions again and again. I just want to show you how I would approach it, right? I just finish sketch. I choose this. I extrude it out to minus 35. I choose minus because it just showed the direction as minus. So that's fine. So this base is over. Sorry. Yeah, the base is created. I think I might be able to scale it a bit. Move. Do I have to edit the canvas? No. Yeah, I can scale it. Yeah, I'll just scale it to a pretty high amount. I'll just move it to the side so it doesn't interfere. So it's much easier to see, right? So I did this part. Then there's a circle, right? So initially I could have done a circle and then extruded it. So I think I'll be able to, let's see, I think I'll be able to do a revolve. I'll just show you how it works. Revolve was completely unnecessary. I could have gone with an easier method of, say, extruding. I'll just show it to you. So there's a 20 and a 20. So that's 20. Inside is a 10 radius circle. Outside is a 20 radius circle. So for revolve, I would have to choose this surface, right? Yeah, I guess there's a 20. I'll just click 10. It has to line up. It has to be 10 as well, I guess. I could be wrong. I could be slightly wrong. I could be slightly off. So the inside is a 20, right? The 20 is a 5, so there's a 10 centimeter offset. Then this is supposed to be 20. Again, so 10 and 10 and 10 on both sides, so that should be 40. Yeah, this should be fine. So if I'm not wrong, there is this line here. I can remove that. So I have this rectangular section right here, right? And I could use this edge to rotate it or revolve it. So if finish sketch, I revolve it. I chose the profile is selected as this one. The axis would be this one, right? And the angle would be 270 because it does not have to interfere. It could be easily wrong. It's fine. I just want to show you. Okay, it's wrong, but now you see how revolve could be used, right? So far, what I did is I drew this thing, I drew the thing, I just revolved it. Now I have to remove this excess so I can show you how to use the cut tool, right? Or the extrude cut. So I just choose this surface. I choose to draw on it. I use this circle and I project the circle first, right? I just chose this particular diagram because I can show you most of the tools I explained earlier. So I just got the center point. I just extrude. I just create this, what do you call it? The circle, right? Since I have extra lines, I have a particular sector. I can select it separately. So I can use that to cut. The sector alone can be used to cut it. So I can just drag it and cut it. One other way to do it is once you select the profile, right? You have to choose the distance to which it has to be cut or extruded. So instead of manually typing in, you can just click on the next face up to which it has to be cut, right? So if I click this, it will snap to 35. So that is a neat trick you can use. I just okay and cut it. I guess I got that portion right. This particular triangular feature, I can model it by using a separate plane and all that. But there's this feature called rip, which I would like to show you as well. So I'll probably be using that. So I'll just move on to this oval-like shape, I guess. So the oval or the circle has a radius of 25. It's a radius, not diameter. It's a radius of 25. And the center is, I guess, 25 from this edge. So I have to extrude it from this face. So I'll choose that face to draw on, right? I'll just draw a circle of, what was it? A radius 25. So that's diameter 50. Let me just rotate it so you can see better. Yeah. Now what I would do is I have to center it to this part, right? I can use this dimension tool because I haven't used it as much. I do 25. So it did that. Now I have to center it in between, right? So I can use, so that's 35 by 2. That's 17.5. I mean, something along those lines. So just center, right? So it's a finished sketch for now. Since these lines already exist, I can use that to separate the geometry I want. Or as if it wasn't there, right? We could just go back to that last sketch. I could click on the surface or this entire. I could click on these two lines. I could just project them, right? I can just project it. It's not required. I'm just showing. I'm just trying to include all the features I've shown you so far in a single drawing. So I'm just using all these unnecessary ones. Now I can use the trim tool. If you remember, it's T. The shortcut is T. I can just cut this excess. Cut this excess. I don't know if there's excess here, but there should not be. And I click OK. Now there's a single close profile. I can use that maybe. I can just click on that profile. I can extrude. As you can see here, it's 20 up from the base, and it's 10 up till here. So 20 minus 10 is 10. So I just enter 10 and it's okay. I could use a hole to make the central hole, right? Or I could have just gone back to the, let's say, what do you call it? The timeline. Gone back to the sketch on the timeline. Just created that circle here. It was radius or diameter 20. I just created there. I click on finish. It doesn't update immediately. So that's because the contour or the profile, the close profile selected was different from what we began with, right? So you can just choose the extrude tool, and in the profile selected, you just clear it and choose the only part you want. So that creates that, right? That was just some misclicks, don't mind that. So this much is done. Now the bottom part. So from here, okay. So this is the surface I would like to draw on, because it's the edge of the surface, and I have to extrude it along or into the object, right? So I'll choose this, and I'll create a sketch. I'll just find the okay, you know what? I'll just choose this particular line. Let me just project it onto that so I can get a midpoint easily. I should be able to get a midpoint easily, right? And it creates this kind of a 7-like shape. Let me just create it from the middle. You go out a bit, you go 90 degrees, you go in a bit, you go inside a bit again, you come out, and it should be. I just create the random shape first, so we can do the dimensioning now. If it's not clear, the bottom should be. I think I made it much more difficult than I needed it to be. It's fine. So these leg parts, inner part are 30 apart, so it's 15 from the middle, right? So I think I should be able to do that. So if okay, I won't be able to do that. That was pretty dumb of me. It's fine. You can just that's 30. This much is 30. This much is 60. Remaining is 30. So you split 30 on both sides, so that's 15. I would assume the math could be a bit wrong. Fine. Normally, you wouldn't need to go as far as what I have done here, but it's fine. It's just a way to learn. You just the scale. I guess this inner surface is 50 total, so half of that should be 25. It's getting the shape now. Okay, now we need this thickness, right? So it's 20 up and 15 down. So the region in between, that's 5. Where is the region in between? So this should be 5. Yeah, I mean it's getting very close, to be honest. It's 5, and now we need this thing's length. So this should be 20. It's already 20. That's good, I guess. See, now we have one half of it. Now would be a good. Oh, sorry, I have to click on it again. I select all of that, right? I shift click on the ones I do not need. I shift click on the mirror line as well. It doesn't seem to work. It's fine. I just click on the mirror option, right? And I click on the mirror line. Nice. I guess there isn't a line there for some reason. Let me just draw it in case it wasn't there before. The case with Fusion is that it's a bit more lenient when it comes to mistakes, I guess. So it let me do a lot of overdrawing, which is really not suggested. I guess I wouldn't stress on it that much because I'm just trying to explain the different parts. I have to remove it from that, I guess. Yeah. So make it a point to note, right? You cannot include the mirror line in the objects. That is why I couldn't select it earlier. I just mirrored it. It appeared as a single sketch. It's fine. So now what do? I just extrude this bit and this bit, and I choose this point, and it extrudes to that length. To be honest, I think that's most of it, right? But yeah, there's this one more tool I'd like to show you. So I think I was able to use extrude, revolve. I couldn't use loft because there was no need. Sweep also I couldn't use. Most of the 2D tools I did use in this particular example, right? Okay, yeah. There is this one more feature in this particular object, right? This particular thing right here. This is what is known as a rib, I guess. Rib is the usual terminology used. It could be called it's basically supporting structure so that this doesn't have too much shear on it, right? So the way in which you'd create that, so rib is used a bit differently. You've seen the rib tool here, right? See, you can use an open sketch curve. Usually, I told you earlier, most of the 3D features would actually require a closed curve for it to work properly, right? But in the case of rib, right, it can use an open profile. I'll show you how it's done. So basically what you need is, you need a single reference line which marks the exact point where it would occur. Basically, you see this dotted line. This is what we are going to replicate as the sketch for our rib. So it says it's 20 units, I guess. We'll just say it's millimeter, it's fine. It's 20 on horizontal axis, and it needs to be tangential to what this thing is, right? So this will give me a couple of opportunities to showcase some of these plane making and a bit of the, what do you call it? It's called a constraint. It's a sketch constraint. So first you need the plane to draw it on. I could have done a much difficult job with this one. The rib is the way to go though. So first you go to construct, right? You click on it, you check the options. The best suited one is mid plane, right? It creates a construction plane at the midpoint between two faces of work planes. So I need the point between the plane between this one and this one. So I'll just select one plane. I'll choose the other. I remind you not to use the shift here. It's not required because more than one entity can be selected as a part of the selection, right? So as you can see, they already generated a plane in between the two. It's exactly midway. So I select that one and I select sketch. So there is two conditions. The horizontal, the resting horizontal has to rest horizontally 20 away from this particular corner point, and it has to be tangential to the particular curve, right? So let's say I just choose a line, right? Usually I would have to project, but I guess since it locks onto the grid, the picture, this particular face, I don't have to use project. So I'll just draw a line like this, right? It doesn't have any particular dimension. It's just resting on it. So now we can use, okay, let's try to use dimensions to center it here. Sketch dimension. So we need, I should be able to choose this point easily. Yeah. Okay. No. Okay. So it won't let me click on it as easy as I thought it would be. So I guess I'm going to have to actually, yeah. So let's just delete that line. So if I had projected, maybe it would have let me chosen. I just choose the center point. I just go 20 here, or 200 is, it's 20 and it's, okay, now I just draw this, I don't know, somewhere. Let's say there. So if I can actually drag and move this line, right? One way to make it tangential is to just ease along the surface, and it should, I wouldn't click, okay. So here we definitely need to use the project one. So I need to make it tangential to this particular curved surface, right? So if I selected the curved surface, I clicked on P to project and I clicked OK. As you can see, there is a violet line projected on. I can just remove the body and I can show you. See, the violet line denotes that particular curved surface, right? So now I can simply drag on this and let it slide it along this till it centers. Yeah, I think that should be, see, it automatically snapped onto that point. So I would assume that is a tangent snapping. Or instead, what I could do is, you see these options right here. These are all 2D options. So it's horizontal, vertical, it's coincident, it's tangent. So what we need is tangent, right? So you click on tangent, you click on the line, and you click on the surface, and it automatically slides it onto that, right? And as you can see here, there's a small indication of the tangency there. I shouldn't have finished sketch. I should have double clicked that. Now if I move it along this line, it'll try to obtain the maximum tangent length as possible. Okay, this one is also moving, so that is not ideal. I mean, if it's tangented at one point, it's better to just trim the excess off. I just use a trim tool, okay? It's trim as T, and I just cut that excess part off. Now it's tangent. And now it's there. Okay, fine. Now we can use the rib tool, right? So rib, you need to select the curve. It says curve and not profile. See the profile, if it would have said profile, if it needed a closed curve, right? It just needs a regular curve to do this thing. So you just click on the curve. There's a thickness value to it, right? It can be as thick as you want. I guess there was an actual, yeah, it's written 10, so I'll just enter 10. So sometimes you might have to flip the direction. So in a lot of cases, it actually does show the flip direction, right? So if it was the other way around, I don't know if you actually understand what's happening. I think most of you can relate. It just flips the direction. Rather than going into the object, it goes out of the object. Sometimes this is required. We need the other one. And we click OK. Okay. So that should be it. I think that should cover all of these images. So as I've said, this probably wasn't the easiest way to do it, right? I did it so I could showcase all of those functions working together, right? So you saw how I chose the sketches or chose the surface to draw on. So yeah, what I would do is usually choose the edge of the surface to draw on, and then from the edge I would extrude into the object. That's just my way of doing it. You can get any convenient surface and you can even extrude to either side, right? If I just select this, so there is this direction one side, right? You can choose two sides. You can extrude one, you can cut one. This is not ideal, like in the actual case. So that was an actual option, right? So I could have gone either way. See, that was the thing. I just choose to use the edge of the piece to draw my sketch on, right? So that is how I intend to use it. So I think that should cover most of the modeling bit. If we do have time, I could show you a bit of assembly. Are any of the coordinators here? Hello? Hello? Yadu, is it fine if I take a bit more time, or I can stop here? It's fine. The portion for the actual workshop is covered. It was meant for modeling, and all of the modeling tips and tricks, I guess, all of them are over.
Okay, like if you want to take it, it's fine. Like, how long will it take?
I can show the basics in 15 minutes, I guess.
Yeah, then it's fine.
It's fine?
Yeah.
Okay, oh, I forgot to ask everyone, does anybody have questions? Anybody, if anybody had tried it yesterday, I think you could come up with questions. It's fine if you don't, I'll just move on to assembly. If anyone has questions, please feel free to, ask. Okay, I'll just show you a bit of assembly as well. How do I, yeah. So I'll just save this. Anyone can ask in between, anyone can interject, it's all good. It's just a bracket, I guess. Okay, so yeah. Okay, I'll just show you this simple quick return mechanism. It probably won't be quick return, but it'll still be a mechanism at least. So as I mentioned earlier, right, in Fusion, you can use it to create individual parts, of course, but I guess where these programs really shine is you'll be able to replicate motion or movement, a bit of force as well. You can constrain the 3D elements in such a way that you can actually create different kinds of motions, right? So as you can see here, I have completed this one. It was just for show, I guess. Does it actually work? Okay, so I'll just show you the basics. I don't think I have any pre-assembled ones. Maybe I can choose the older version if it's still there. This might work. Okay, yeah. This is an already assembled version, okay? So the work has already been done. By work, I don't mean there's much to do actually. So what it does is, as you can see here, there are different constraints given, right? As you've seen, the tangent constraint and the vertical, horizontal, the coincident constraints. Similarly, those constraints, when given in 3D or three-dimensional space, you can very clearly determine motion of this objects, right? So I've given a couple of constraints right here. I'll show you what it does. As you can see, this wheel is known as the crank, and by the motion of the individual parts, it should be able to reciprocate this particular red cylinder within this casing, right? So if I was to rotate it slowly, I do the rotation slowly because there's this thing called collision set or contact set, right? So as you can see, as I rotate it, all the parts are working in harmony to generate this particular kind of motion, right? So that's all good. So that is what I would like to show you. In Fusion, it's very easy to make the, let's say, to make these motion parts. Some of these are a bit offset. I'll just show you how I do it pretty fast. This is not part of the workshop, but I mean, once you get the modeling part done, you can easily manage most of the other stuff, right? So all of these are separate parts. All of these are modeled separately. This is just material given, right? Material is just appearance. So you click, I guess, is it insert? No, it's create. I guess it would be modify. Modify, there's an appearance tab, right? I just click A and so the appearance, so you can just drag and drop the appearance, right? It's not important. It just helps you to split apart pieces. Since the workshop was about modeling at first, it would usually involve a single piece. So hence I didn't really get into the appearance part. So this capture position, convert position. So that means if I move any object in space, that is the new position. I could capture it or I could revert it back to the home position. So I'll just get to the simpler parts. So in Fusion, you have to align the objects first, right? And you can join them later on. The thing is, usually when I did create this model, I made the model in such a way that it was already pre-aligned, right? I moved it apart just so I could show you the options. It has quite a bit of timeline. All of these are simple parts, some simple cuts and all that, but still, I should be able to show you how it works. So all this comes under assembly, right? As you can see, it's the new component. So none of these are bodies. All of these are components, right? Only components can be moved about by dragging them. And in every assembly, you have to have at least one fixed object, right? So I chosen this base. See, you can actually ground it by right-clicking and clicking ground. It's ground now, so it shows the unground option. So even if I try to pull it, it doesn't go along with me. I can pull any other part, but not that one. So let me just show you how it works, right? So if I was to like, okay. So this crank, right, the yellow disc, it has to fit here into this slot, as you can see, and it has a pin right here too. So I know this edge of the pin has to go into this particular edge, right? Those two edges have to be in contact. So that is where my alignment comes first. So assemble and no, not assemble, it's modify. Yeah, it's modify. The align is in modify tab, okay? So shift A is the shortcut. I might use it. So I just from this place. So I choose the circle here. And I choose the circle here. And as you can see, it's snapped onto there. The thing to notice, the position is not fixed, okay? If I click revert, it will just go back. So I'll just capture position. And now if I move it about, it will still move away. I can revert it back. Now if I give the joint, right, or the constraint, it will be able to stick there. So what I can do is click on as-built joint is useful when all the components are in place. I can use it here. I can show you both. I'll show you simple joint first. I select the joint, right? I guess, yeah. So the first component to be selected is this one. And the second component to be selected is this one, right? Now they automatically try to take this kind of a motion, right? So it's set as rigid. Rigid means fixed, and we don't want that. We want revolute. That is, it spins about a certain axis. We choose that, and automatically the axis was selected, so that's good. And we could click OK. And as you can see, if I try to drag it along, it just goes, right? It follows the what do you call? It follows the motion of. It follows the constraints. That's all. And it has a particular angle here as well. It's 161 something. All those joints appear here, as you can see, right? If I were to double click, no. Edit join limits. Okay. So this has a couple of extra options as well, such as lock and edit join limits. Lock means it just locks it in place. It converts it into a fixed joint. You can unlock it later on. It's fine. So you can edit joint. I want to edit joint limit, right? I just want it to be 0 degrees. If I can manage it. Okay. I guess I have already messed it up a bit. It's fine. I just want to be centered so I can show you later on. It's fine. I guess. That is 89 degrees. Okay. Okay. So the best option would be minimum. Minimum is 90 degrees. I just did that to get it exactly in line. I just remove this minimum and maximum. Minimum and maximum basically determines the limit up to which you can move it, right? So if I applied 2 limits there, so I think I messed it up. I do not know how I messed it up. Edit joint limit, yeah. The maximum should be 90. Yeah. So if I did this right, it cannot go any further than that. It just gets locked there. So for Revolute or sliders, all of these options apply. So let me just remove those joint limits. Edit joint limits, minimum is 90. And I just remove the limits altogether. It's fine. It just needs to stay there. Then similarly, I had this piece to join, right? And it has to fit somewhere here. I modeled this because I knew what has to come where, so I just apply it here, right? Basically, I know where it is going to go, so it makes it easier for me. So when you design your own thing, it should be much easier. Now, since I already aligned this, I can show you the assemble and the as-built joint. You just select the 2 components, right? And they all automatically detect the type as joint Revolute. That's what we need. What they say about snap is they basically want the joint origin or the axis about which it has to rotate. They'll just choose it here, which is convenient. I just click OK. And that should have. And for some reason, it doesn't center as easily. I mean, this is fine for the time being, I guess. The reason I want it there is because there's this thing called contact set, right? So it's always better to establish your constraints using these joints, because contact sets or collision sets, they actually have to physically calculate each contact with individual faces, right? So it's a bit taxing on your system. A single one wouldn't hurt, but it's better to avoid them. I have to use it here because there is no other way. It's under enable contact sets, right? Then I go new contact set between this face, this body, and this body, and I click OK. And if I did it properly, as you can see, as I move it slowly, right, or if I rotate it slowly, they are actually calculating the contact between this body and this body, right? However, if I were to do it too fast, right, it gets out because it cannot calculate as fast. I'll just revert it. So this makes it easier for the entire mechanism to work. Let me just set this as that is not ideal. I'll just revert it. It's fine. It's a lot of unwanted work. You can avoid it altogether, to be honest. Okay, for some reason I'm missing. I don't know why, but it seems to be missing a certain slot, I guess. I don't know what happened. Let me just quickly play. Yeah, this is another important or easy use when it comes to Fusion, right? When you are working with assemblies, you can pretty easily make corrections. So yeah, this is another easy tool. You see this inspect one, right? I just click that and click this one. It gives me all the information I need. It's a radius 1.5 or diameter 3. So I need to create a slot here. For some reason, it capture position. I need to center it, so I'll just project that particular piece to get the center, and it needs to be at 3 mm, right? Yeah. I just click this and extrude up to this point. I don't know what happened. It should not have left me, but it did. It's fine. Now, as I mentioned earlier, you just have to align things. By the way, I'm using the Shift A shortcut. It just makes things a whole lot easier. And I guess the Shift J shortcut is for ASPL join. So when you're using software, it's very essential that you learn the shortcuts. It just makes your work a whole lot easier. I guess I would recommend it. I would recommend it to everybody. So I'll just move both of these. That's just a simple drag and drop, okay? There was nothing complicated about it. Just the thing about this, okay. Now, since this already slotted inside this, I would have to Shift J. It's not revolute, okay. So this has to be a slider, right? Because it has to go in and out in a. It has to undergo translational motion, or it's a translational motion. It's a straight line to and fro, right? So it shouldn't be revolute. It should be either slider or cylindrical. So cylindrical means if you just imagine, it can actually rotate in the axis of the cylinder as well. We actually just need the slider. We can get away with the slider alone. If you animate it, it doesn't show. Okay, fine. So I just take a snap point. I need this to be the direction. Yeah, this is what I want. So that's fine. That's okay. And let me just try. This might probably go wrong. In most cases, it does go wrong. It's fine. Yes. I just select this surface and the surface. Yeah. That's the. Why is it's fine? You see, that's the problem. I guess I have to. Let's just try to align this first. Now it works. So if I were to, I do the Shift J, just ASPL join. So that which means the orientation or the alignment is already done, and you just have to click the points and choose. This is not a slider; it has to be a revolute, and the snap should be this axis. Yep. It's just stuck. That's fine. Yeah. Okay. Now this outer cylinder surface should go into the inner cylinder surface. Cylinder should go to the outer. Yeah. So it goes from to to approach, right? So if you want to move this to this, right? If you want to do this, you click on this first, the second. I shift click those, then I click the Shift apply, the Shift A, which is for align, and it moves it to that position. And let me just capture position. Now, if I were to click on both of these and click revolute, no, slider, yes, snap, yes. I mean, it should have worked. Yes, it's not working now. And why is that? Yeah. I guess I have to try cylinder Q then. And it's fine. These kinds of problems do happen. Yes. Oh, yeah. I just give it cylindrical, it's fine, because the other constraints should hold it in place. Now, if I have to move this, right, it's better to have the cylinder ground as well. So just ground it in the browser, right? So if I were to move it right now, yeah, you can see it works. There's a bit of a problem, as in this goes out. See, this is what I was telling you. If I were to rotate it further, see how it intersects with this. If the contact set was enabled, right, that shouldn't be a problem. But it's better to keep contact sets to a minimum. I think it's just better to unground it first, right? Unground, then you M is for move, okay? Or this, you can use this. M is for move, and you just move it along the surface. I think that should be easier, right? You can avoid a contact set entirely by just moving it. And if I'm not wrong, yeah. As you can see, the entire motion is replicated. And when I got too excited, I just rotated it a bit faster than I would have liked, and it got out of the slot. It's fine. See, the thing is, you can just use it. Like, I could say I successfully did the whole mechanism. It works. All of my dimensions are correct, and hence I'm able to create this kind of a motion. So that's just a little about assemblies. Focus a bit on the modeling part first, right? You can go to assemblies. I would recommend getting the modeling part done right, so you can make your assembly section a bit easier. Okay, so I guess that would be it for this session. Thank you for tuning into this workshop. Any questions? Anybody? Anything at all?
Hello.
Hello,
Sir. Yeah, how should we 3D print this object, this project?
How do we 3D print the object?
Yeah, what's the
Okay,
process
so
that we should do in this software?
in Fusion, I guess they have a direct option here. Are you familiar with the STL extensions? It's basically just a file extension, right? Like JPEG for images, MP4 for video files. STL is just another 3D, let's say, a 3D file extension, right? So in most cases, if you have a 3D printer at home, I guess you could just go to the 3D print option and just select the whole thing. And it's, I wouldn't really, what do you say, recommend the direct approach, right? You could do it. What I did was we actually gave it to this separate, we had this lab. I think you'd be familiar with the, what do you call it? TPLC, TBA. There's this TBA section, right, in the college. So they usually handle most of the 3D printing. But I'm pretty sure they used to export the file, right? Sorry, not that. I'll show you. Okay, so from this file, you can export, right? You can export it as an F3D file. This wouldn't help us much. So instead, go for the step file, or I think some people prefer the STL file, right? You export that and you use it on a software specific for 3D print. That would be better, as you could gain a much clearer control. I'm sorry, but I'm not really familiar with the Fusion 360 3D printing. Does that help at all, Amit?
Yeah, yes, sir. Thank you.
Okay. Anybody else? Something preferably related to modeling? It's fine. Otherwise, Amit asked a good question, because the end goal of this modeling is to prototype it, and 3D printing is usually the way we go. There is also this, what do you call it? To the tip of my tongue is CNC cutting, right? So there is this option for CNC cutting if it's a sheet-like material, right? If it's finer parts, like let's say some kind of brackets, right? You can actually CNC cut, because you need a much stronger material for that. So what we would do is usually we let's say you want, yeah, I guess you could use this one. If you wanted this piece, right, this connecting rod, so it's loaded lever, yeah. So you create a sketch, capture position, whatever. You create a sketch and you project this entire thing, right? You project this entire thing. Where is the project option? Yeah. And you project it and you click OK, right? So you get a new sketch. So in the case of CNC cutting, right, you cannot. Let me just hide all this other stuff. In CNC printing, you do not actually use the 3D file as such. Rather, you'd use a known dimension and a shape file, right? It's called a DWG, I guess, Adobe DWG file. So now I got the sketch, right? This sketch 24. If I right click it, there's a DXF, sorry. It's a DXF file. If I save it as such, let me just save something. The connecting rod. The desktop. So I don't think you'll be able to open it with the default applications on your system. It's a DXF file. So I'd assume you'd have to, let's see. DXF viewer. Your drawings, open in file. It's just I don't have the exact software for it. I think you can just download. Okay. Online DXF viewer. I know this isn't what you asked, but to be honest, this was very useful, right? For when I was working on this particular project, it was about Pravega. It was about building a car. So that was pretty useful. If it works, it works. So this we needed to do a lot of CNC cutting, right? So we had to export it, and I didn't know at the time. I had to play around with Fusion a bit to get it. If it loads at all, that would be nice. As you can see here, it's a black and white image. It's basically a sketch file, right? So so any CNC cutting shop, you just give this and tell them like this point to this point is a particular measure, right? They'll get all the other measures from the calibration of the machine itself, and they'll help you with it. So that's how CNC cutting is done. I am almost sure you'll have some or the other application for that particular tip. Yeah. Anything else? Anybody? Anything at all? Okay, then I guess we can conclude the session. Yadu, or is it Dave? Hello.
Yes, sir. I think so. No more questions are there. So now I invite Kalyani Chechi, chairman of the ISTE Student Chapter GECB, to present a small token of love to Nihal Chetan. Over to you, Chechi.
Hello, am I audible?
Yep.
Okay, 1 second. So, yeah, thank you so much, Cheta, for taking this amazing sessions and the further encore session that you gave despite your extremely busy schedule. And here's a small gratitude, token of gratitude from our side, the team of ISTE GEC, and I'm sure the session helped our participants a lot. And since we have a full-blown vote of thanks from Devanarayan, I won't be taking any more time or words from him. So, over to Dave.
Okay, Chechi. So on behalf of ISTE student chapter, I would I give a really heartfelt thanks to Nihal Chetan to taking his time and conducting a wonderful session, and also the EXICO members who without would not be a smooth running of this wonderful session, and also not the least the participants who were there throughout the session and ask the questions. And I think so it was very beneficial for you guys. Thank you everyone for conducting the session, for joining the session. And now I'll be posting a feedback form in the chat and the group. Please do survey it and do all the questions asked there. Thank you everyone.